So, IoT architecture and communication technology. Syllabus IoT architecture by Oracle, source of IoT, M2M communication, IoT, M2M system layer and design standard communication technology. Now we are discussing about IoT architecture by Oracle. The thing of the Internet of Things is network of physical objects, devices, vehicle, building, and other items embedded with electronic software, sensors, and network connectivity that enable this object to collect and exchange data. IoT is a connecting every physical object in the world using wireless. So, Internet of Things are able to collect and exchange data using embedded sensors, physical object plus controller, sensor and actuator plus internet is equal to IoT. Gather plus enrich plus stream plus manage plus acquire plus organize equal to IoT with connectivity to data center. Gather plus consolidate plus connect plus collect plus assemble plus manage and analyze equal to IoT. Anytime connection. On a mode to day night between a PC human to human communication, anything connection, any place connection outdoor means it connect with the databases and outside. Let's discuss various IoT characteristics and features, advantage and disadvantage. IoT is an intelligent machine, so it can be do its work uniquely. Connectivity. So there is a high connectivity present between it, thereby which is very important. Sensing. It sense environment through sensors and give actual information for environment. Expressing it can express all those data in term of data, all those things. Safety, energy. There is a required less energy for it, so that's safety. Safety is also important because we need to communicating with IoT devices and features device virtualization, high speed, endpoint management, small devices, team processing, data enrichment. Advantage. When it comes to advantage, integrated of devices, reliable servers, enhancement data, reduce waste, real-time analysis, important improve engagement, automation and technology. Disadvantage: security issues, privacy issue, complexity issue, flexibility, compliance, tier 3 management. So there are some tools technology we use in IoT such as RFID, Wi-Fi, barcode, QR code, Zigbee, sensor, smartphone. These are nothing but technology we use in IoT. So you can see Arduino, Respiratory, Azure, AWS, Intel. Let's see about IoT architecture. IoT applications. Start from devices because without devices we cannot connect anything. Then it comes to service provider. Service provider come basically business or operation or network security who provide a service to this. And then in point to come infrastructure platform where devices management which devices to connect where and machines to IoT services. What IoT service? IoT services come on the point on four part because before that without network this all those things nothing is possible. So that when IoT services come, the IoT give event processing, integration, security, identity management, user interface, big data analysis. This all those things IoT services. So when a developer come in the point, then developer portal, developer APIs, third party APIs, service provider, then actual use case of a IoT. IoT play crucial role, but IoT come in the picture after all this thing completed. Okay, that's great. Let's discuss us about architecture view. In architecture view, mainly IoT gather information and enrich, stream, manage, acquire, organize, and analysis. This is a very important to gather information To gather information, smart sensor uses IoT communication sensor and enrichment. We use application framework, IoT communication model, IoT communication framework. So when it comes to stream, we use various protocols to do it. So communication protocol handlers, message router, message chache. To manage those all protocols, you need to do something better because internet is connected. Then you need to manage it. Of course, you should manage it using databases, access management, routings. And after running management, you should do acquire it because after managing all those things, you should acquire now. For acquiring it, data center you need data store, databases, organize. After you getting also databases, you should organize where should it coming, how can I use it in my future because if you cannot use it, you cannot do it. That's it now. It is very simple and straightforward. We gather information, enrich and stream and manage and acquire. That's it. Gather, enrich, stream, manage, acquire, organize. Okay, that's it. This is all the stuff you can read it out, but let's think about sources of IoT because when you are dealing with IoT, you should know what are the sources are in IoT. These are very important because if you do not know which source you are using, then you cannot be grow out of it. Because let us see Arduino UN. Arduino UN board uses microcontroller. Let's see what is a microcontroller. A microcontroller is nothing but one machine which is used in our computer. Then in a picture come of the Arduino. Arduino is nothing but USB portal used for that, Wi-Fi use, and the board also combined with the earthiness. So then in a picture come Microduino. Microduino is a small board compatible with Arduino that can be stacked with other devices. Intel Galileo. So Intel Galileo name itself suggests that is designed from Intel. Galileo is based on Intel x86 architecture. It's open source. Because of its open source, you can contribute toward it. And Galileo is a pin compatible with Arduino. It has a 20 digit input output 12 GPI cumulative bit. So then point come to Intel Edition. Intel Edition is compute module. It enables creation of prototypes and fast development of prototyping project and rapidly producing IoT and wearable computing devices. It enables seamless devices, interworking and device cloud communication and interface foundation tools. The tools collect, store and process data in a cloud. So cloud is nothing but something that store in a internet data. Then in a point to come, another one is nothing but bagel board. Bagel bone is based on a very power requirement. It card like computer which can run Android and Linux. Both the hardware design and software for IoT architecture open source. Let's come on the Raspberry Pi wireless investor. RASVIK enable Raspberry Pi Wi-Fi connected device. M2M machine communication. Machine to machine communication refer to process of communication of physical object or device at a machine with other of same type, mostly for monetary bus also central purpose. Each machine in a M2M system embedded a smart device. The device sensor the data or status. M2M to IoT and IoT technology industry. You can see it, IoT architecture M2M. M2M architecture consists of M2M device domain, M2M network domain, M2M application domain. Okay. Then after it, M2M architecture consists three domain. M2M device domain, M2M network domain, M2M application domain. There are three domains only. Person. Okay. M2M application domain, application M2M network domain, M2M M2M device domain. So M2M device domain contain communication gateway, and there are a lot of things. Network domain contain M2M server, and M2M application domain contain integration collaboration. Okay, that's it. You can see it now. Then let us see about ITU reference model. ITU reference model, its current spawned model of 6 layer modify OSI model. Application server, service, support, network layer, device layer. ETSI network domain has a 6 capability. M2M application, M2M service, M2M management, M2M network management, core network, 3G, IP network, access network, ETSI, M2M device, ITUT reference model. Then in a ETSI M2M domain architecture, there is a two parts. One is a deal with basically with applications, and the second one deals with the device and gateway. So mainly application and device network are important. Further, it is very important to do it. Let us see about communication technology. When it comes to communication technology, we need to see a lot of things, because communication is a part of, because if you want to communicate with devices, to communicate devices to device, you can fulfill IoT dream and goal. Let us see one by one. Physical come data link layer in a model consists of local area network, personal area network, and a local network of IoT M2M device deploy one of two type of technology. Such as one is wireless or wired communication technology. Figure below show that. Let us see figure one by one. There are multiple devices are present. Using IoT area network Bluetooth, these devices are nothing but connected, because in a devices communication we use Bluetooth, smart IP address, Zigbee, 6LoWPAN, RP plan, network protocol. These are very useful tools. We use Node. But let's see about very important subject, very important concept is near field communication. Let us see one by one what is near field communication protocol. Communication. Near field communication is so IEC standard of contactless priority card. NFC is a short distance 20 centimeter and wireless communication technology. It enables data exchange between card and proximity and other devices. So let's see about RFID. In a RFID is nothing but radio frequency identification. It's automatic identification method. RFID uses internet. RFID uses therefore in a remote storage and retrieval of done in data of RFID. The RFID devices function as a tag or label. There is only two functions of a RFID tag. It's nothing but tag or label, which may be placed on object. The object can be tracked for a moment. The object may be parcel, person, bird, or animal. IoT application of RFID are a business process such as a parcel tracking and inventory control. We basically use RFID for a parcel tracking, inventory control. If you wanted to see about parcel tracking, you can see to about parcel tracking. Now see about Indian Post how those people how India Post track our process. Then you can see it on the दरवाजे पे किधर है? So basically Post Bank too with how this they are tracking all those things assignments. You can see it, but it need a specification. Yeah. It's okay. They are using RFID, so that's process of doing it. Let us go with another Zigbee IP address, which is very important. Zigbee device from WPAN devices, network, into point devices, WPAN of embedded sensors, actuator, appliance, controller, or medical data system. It's not a very cellular network, web object, physical data link, data abstraction, application. Let's go move on to it. Wi-Fi. Nowadays, Wi-Fi is interface technology that uses IEEE 80. This is very important protocol. We need to know about it. IEEE 802.11. Let's research about it because 2.11 protocol. So most common access network allow smartphone devices. You can see general description, graduation, then. Wi-Fi connect the distributed WLAN network using internet. Automobile instrument, home networking sensor, actuator, industrial device, nodes, computer, tablet, mobile, printer, many devices have Wi-Fi interface. They network using Wi-Fi network. Wi-Fi is very popular. The issue of Wi-Fi interface APS router are highly power consumption, interference, and performance degradation. Wi-Fi interface connect within a themselves or to an AP wireless router using Wi-Fi PCI card. Build in a circuit card and through following base station AW LAN transceiver or these can be connected one or many wireless devices simultaneously to internet. Peer-to-peer nodes without access point. Client devices within an independent basic service set network an easy setting of 802.11 network pair to multiple nodes with a basic service set. Using one in a between a AP point or distributed BSS connect through multiple AP. Connectivity range of BSS depend on the range of wireless bridge and antenna using an environment condition. Each BSS is a service set identifier. Service set identifier. Figure below shows that WLAN network BSS sensor devices nodes network with IP4 network. Here is disable connectivity. You can see it. Tablet, Wi-Fi, computer, BSS, all those things. But let's see what is the diagram showing us. Physical layer, Bluetooth, mobile devices, laptop, Wi-Fi, PCM, Wi-Fi, laptop, mobile, Wi-Fi, TCP, UDP, ICMP. What is the ICMP? I don't know. ICMP is nothing but the Internet Control Message Protocol. Internet Message Control Protocol function. It is used to reporting error and performing network digestion in error reporting protocol. So let's move on to the another part. 3 WLAN network for a sensor devices node. Mobile, tablet, laptop, computer, and internet connectivity of WLAN network with IP4 network. Let's have into the easy our installation simplicity. It's very easy to install. Uses 802.11b and wider coverage range because that unaffected by walls and the mean for Oxford for public usage having a range data rate 11 Mbps and 802.11b within the 330M. So when you uses 802.11g for a high data rates up to 54 Mbps and 802.11m for very high 600 Mbps using multiple antenna to increase infrastructure which ensure compatibility, enable easier access and idle complexity with when enabling the wireless access to data. Media and stream applications and services provide dynamic environment of network, exponentially scalability, provide security, integrity, reliability, uses personal protected access, wireless protected access, and wired equipped privacy security extent. Okay, that's it. Let us see one by one all those things in detailed manner because this is lower energy. It's up to frequency 240 Zigbee 86 NFC near. Its frequency is less. Channel of course Bluetooth has 3, Zigbee has 14. What is Zigbee? I'm confused because that how much after learning also I am forgetting about Zigbee. Hmm. Zigbee's wireless protocol is used for everything for IoT devices such as light bulb, socket plug. Zigbee's wireless network or Zigbee has a network range up to 70 meters and Okay, that's it.